All right, let's look at the homework 2.6, problem number 3. All right, so we have a spring and mass spring system. So the equation is mx double prime plus kx is equal to, and outside force is F0 cosine of omega t. Right? By looking at the characteristic equation, so we have a characteristic equation is going to be mr squared plus k is equal to 0. Then I'm going to just divide through by m to get r squared plus k over m is equal to 0. Right, so we know that this is going to be, r is going to be, let's see, it's going to be a plus or minus square root of k over mi. So if you want to find a natural frequency would be square root of k over m. Right, so this is radians per second. All right, so let's find that first. All right, then here there's a hint. All right, so mg is going to depress the pad exactly. It's actually a pad, so it's not really a spring, but we can think of it as a spring, exactly 0.5 centimeters. All right, so we know that mg is equal to k times x. All right, then we have a k is 0.5 centimeters. So I'm going to plug it. Oh, actually, before we do that, we can actually solve for k over m. So this is going to be, I'm going to divide through by x, so that you have mg over x is equal to k. Then I can divide through by m, so that you have a g over x is equal to k over m. And conveniently, what we're looking for is a square root of that. So this is going to give us omega is simply square root of k over m, which is the same thing as square root of g over x. All right, so g in this case is 9.8, and the x is going to be, I'm going to have to convert this because this is in centimeters. So 0.5 centimeter is 0.005 centimeters, right? So this is going to be 0.005. Alright, so I'm going to open up a GeoGebra here. Alright, so I open up the GeoGebra, so we just need to compute, let's see, this is going to be a square root of, alright, and let's see, 9.8, so we have a 9.8 divided by 0.005, alright. All right, let's hit enter there. Oh, actually, let's see. Let's hit enter. All right, enter. All right, so looks like we got the 44.27. All right, so this is about, actually, let's round your answer to 2 decimal places. Okay, so this is about 44.27. But this is in radians per second, right? But they are looking for a frequency in hertz. So what we need to do is divide by 2 pi. So frequency f is going to be omega divided by 2 pi. because one cycle is 2 pi, so it just tells you how many cycles you're going to go through per second. So if you do that, and it's going to be A divided by, so A is the value for omega, so A, and I'm going to divide it by 2 pi. So you have a 2 and pi. All right. Oh, actually, I have to hit enter first. All right, hit enter. All right. So this came out to be 2.05 hertz. Right. So if they're looking for the circular frequency, it would be 44.27 radians per second. And if you're looking for a frequency in hertz, it's 7.05 hertz. All right. That's it. I hope that this was clear.